Hello, welcome to your PCB design and build. So I've not done this one before, but I'll give you an introduction to how it works. First thing is just to understand what's the PCB, what's on it. What we've got is a holder for the Arduino, and the Arduino is going to go upside down like that, and it's even got a little highlighter bit. We've got power to the whole system. This will power the Arduino and it will power the motors as well. So what we've got is we've got some connectors. You don't have to use these connectors, by the way, but it's easier if you do. You could just solder directly in, but that's a connector and that's for your main power there. So we'll drop those in and solder those in shortly. Okay. First things first. Oh, what else have we got? Oh, sorry, yeah. So we've got the power. We've got a switch that will go in here. So we have a switch. It's one of those switches, and then it will go through a fuse. So we've got a fuse holder. We'll just solder in the fuse holder in a minute. And the power itself, it actually goes through this diode to the Arduino. The reason why we have a diode to the Arduino is if we just power the Arduino from a USB, we don't want that power going back through into the motor circuit. So the diode blocks that. So that's just something that we've done as a new version for this. We have a motor driver, which is a very interesting legged chip, which will fit in that way around. And then we have the motor, which will connect to the motor driver. It's already connected to the motor driver, and a few isolating diodes. And then everything else around here are connectors. So you can solder these connectors in. Even though they're in fours, you will just get away with using twos and putting those together. So that's the analog ports, for example. These are the I2C ports. You might be using that, or it's also analog A5 and A4. It's all highlighted on there. We've got 3.3 volts. If you're going to use it, you might not use it. So, you don't have to solder something on. Ground, you'll be using lots of grounds. We have the 5 volts. So we could put those in the 5 volts. And then you've got your digital I/O ports here as well. So what I'm going to show you is how to solder some of these up. I'm going to start off nice and simple. I've already just chosen the correct resistors. I think that might be a 330 ohm resistor, but it's as close as, and I've just put it through the holes and I've got that 180 ohm, and both of those are going to control some LEDs. So what I tend to do is put the resistors in and then just bend the wires on the other side. And what we then do is we get our solder piece of solder. Now Tom has told me about these flux pens. I've not used a flux pen before, but I'm going to give it a go. So I'm going to dab a flux pen on there, and that apparently allows it to flow better. So I'm going to get my soldering iron and just, it's nice and hot, and then just let it flow like that. And the trick to soldering is to heat both bits of the metal at the same time. So both the leg of the component and the PCB as well. Now, with your soldering iron, always make sure there's a blob of solder on it. So when it's left on the stand, you don't want it without a blob of solder. And the way to keep this bit nice and shiny, you want it nice and shiny, is to use a sponge, wet the sponge, so it's got not soaking, but it's just wet. You can rub off any old solder, and then you can just add on the solder like that, and then that's good to go. It's good to do some soldering, or it's good just to leave it on the stand, just being careful it doesn't hit the wire. Okay, so that is the resistors, and I'm just going to snip those wires off to get them out of the way. Keep it nice and neat like that. Okay, right, another one which is an awkward one to solder is the Uno. So that has to go into there. Now there's a trick to this. If you get these connectors, make sure that these connectors are going to be that way around, because the Uno is going to go onto these long connectors. And the trick to this is to put the long side of the connector into the ports of the Uno and either snap them off. If you're lucky, you'll get it right. If you're not lucky, like I wasn't, you might get it wrong, and just trim it to size like that. I'm being a bit lazy with that one. I'm going to put that one in. Remember, it's a long one. And then just break it off. That one worked nicely. That one, break it off. There we go. And the last one, like so. Just break those two off. So what we have is little pegs just sticking out like that, and I'm going to solder those in. Okay, so what I'll do is put those little pegs in. The circuit board has been very well designed by Tom, who's doing the filming here. Okay, now let's try it with this pen. It seemed to work quite nicely, so I'm just going to dab that on. I would say it's not essential to use this. I'd never used one before, but since we have these pens, let's go with it, and it seems to help anyway. So here we go, let's do it all in one go. So you've got your solder flux, and I might just wet the bit again, refresh it. Got my solder a bit, it's a bit long. Gear it on. You'll be able to know when it's actually on the bit. Just going to shorten that a little bit. Can't quite get it. Okay. Wet the bit, and he says, if it doesn't quite go in, then it's not working properly. So make sure that your tip.
Okay, rolling.
You ready?
When you are.
Okay, at me then. Okay, so interesting, we had a problem with the soldering iron, and what happened was it stopped working. So the pool of solder just wasn't taking it. So just to focus on your soldering iron, just when you put the solder on, it should melt like that. So you've got a nice hot little pool of solder like that. Okay, so now we can do it just in one go like so. You only need a tiny bit. Don't put too much on because you don't want one to bridge over onto the other. And you also don't want to hold your soldering iron on too long, because you could, it's not very likely in this case, but you could damage your components because your components are getting hot as well. So you want to really minimize the amount of heat that they're getting. Remember that you're heating up the leg and the little pad as well, but you're not overdoing it. And it's very therapeutic when there's not a big noisy machine outside. Okay, that's one row. Next one. Once you get in the roll of it, it should be quite straightforward. But a bit of practice, you can always practice on legs of other components. It's probably not the best to start on one of these. Maybe just best off to start off with the switch and the resistors and maybe the fuse.
We do have a perf board if you do want to practice soldering.
There we go. Now, so this, although you wouldn't need to do it normally, this that can come out, it could go back on, and it should fit perfectly. Okay, so let's do the switch, which I should probably have started off with the switch. Now, the difficulty now with the switch is because that Arduino is out. I'm going to just move that out of the way, because you always want it to stop it falling through. So that has just about balanced onto something. If you can get a bit of blue tack or something, it's usually a good idea. Now, the size of these holes and the size of the switch legs will need a lot of solder and a lot more heat. So you will need to hold it on quite a bit longer. You can see that's taking it quite nicely there. Okay, this isn't going to be ideal. The switch is going to be a bit skew-if. There you go. That's your switch. And let's put one of these in. I'll show you one of these. So as I said, the switch is a bit skew-if. I'm not totally happy with that, but it'll work. So it's all right for the demo. Again, we can do the switch. Now, it's probably a good idea to, sorry, not the switch, the connector. But you need to, as you can see, I'm just bodging it and holding the connector the best way that I can. And I'm just using the piece of solder reel. But I think if there's a bit of blue tack available, it's quite handy because you can put it on the other side of your components and keep them into position.
Just watch the blue tack, you can melt it very quickly into an oily mess, which can cause problems.
You'll see that the connectors need a bit more heat to them, and I kept the soldering iron on a bit longer, but that would be the battery connector. Then we've got the fuse connector. Now what I've been forgetting to do is to use this pen. Let's try that, see if it helps a little bit. It is alcohol, so apparently it evaporates very quickly. So you have to dib it on and then they'll pretty much be ready to do your soldering straight away. That's the fuse. This is from the main battery. And then, not ideal, and then a diode, making sure that your diode is the correct way around. So you'll see that on the PCB there's a line, and that line tells you which way around the diode is going to go. So you see a line on the diode as well. Like so. So let's get it in there. One component legs, push them through till they're nice and flat. Bend the legs out on the other side slightly so the component doesn't fall through. And solder it up. So once the fuse is installed, that should be all you need to have a battery-powered Arduino. And the next bit will be to watch your eyes when you click these off, by the way. We would normally have an extractor fan, but the noise would be too much for the video. But yeah, you must have an extractor because the fumes are quite toxic. You don't have to put in the motor driver to test all of this out. All you really need is a bit of the power for the Arduino, but let's put the motor driver in because it is quite a facing to do. Make sure it's the correct way around. It's on the same side as all of the components. Remember, you've got a component side and then you've got your solder side. If you've seen any from last year, we did make a mistake and we had to put in the motor driver upside down. So just in case you might have spoken to somebody, it should be the correct way around. As you see now, we've redesigned it. The main thing to watch here is that you don't bridge any solder over from pin to pin. And the other thing to bear in mind is you are actually soldering onto a circuit, an IC, integrated circuit. So you really don't want to be holding on too long with your soldering iron either. So make sure that you do this as one of the last bits that you do when you're confident of soldering, or get someone to help you, another student or members of staff. We're happy to help with soldering. We'd rather, you could do it right. Okay, your motor is an output so you could screw your motor into there. Again, I'm going to use the soldering reel just to hold that into position. Oops, no I'm not. Put it back. And there should be 4 diodes, so if I just solder this in, and I'll just show you where the diodes go. And then what I'll do is I'll just talk about the LEDs, light emitting diodes. Okay, so that's for the motor. Ideally, you'll have 4 diodes, so you can connect your motor diodes. Remember that they have to go in the same way around, so there'll be 4 diodes there, which stop any back EMF. It's up to you which color you choose for your LEDs, but make sure that your LEDs are the correct way around, and there'll always be a little flat bit on the LED, and I can just see a flat bit, and it's the short leg. So the short leg is the flat bit. So it goes in that way around. So flat bit to flat bit, and you can see on the PCB that it's there as a flat bit. So you can put your LED in nice and flat. It doesn't matter which colour you use, and what I tend to do is just bend the leg slightly like that, allowing the LED just to fall about 1 millimetre away. You really don't want to heat this up too much, so when you're a soldering expert, you really want to be less than a second on those legs. To drive the LED, we have a resistor, and the resistor is the one that I put in already. So the 5 volts power, 180 ohm resistor. The 7 volt power is 325 ohm resistor. And that really is all you need. Now it's up to you how many of these you want to put in. You can put a few of these in if you want. You don't have to populate all of it. You might not need all of these pins. You can have some just to start off with. But once you've put these in, you probably won't need these ones. You're good to go. One more thing I've just forgot to mention is you'll need 3 pins for the servo. So the servo motor is for the steer servo. And you can just snip off 3 of those and put them in like so, like that. So solder them in. Okay, here is my button. So we've just found out I've made a mistake. I'll take full responsibility. It says D10 on here to activate the servo. It's actually D13, so we will issue that. D10 is connected to one of these pins on the motor driver, which is in one. So to drive a motor, first enable it with D11, and then D10 and D12 are either high or low in order to drive the motor one way or the other. Either low and high makes it drive one way, or high and low makes it drive the other way. So that is D13, not D10. So we are a little bit gutted that we found that, because we thought this board was the absolute best ever board. Well, it is, but there is a slight problem with that's it, but that is the only problem we've found with it. Just another couple of pointers. I've just put in these diodes, quite badly actually. I'm going to test it out in a minute. There are some little slots for diodes. You'll see C2 here. There's C1 here. They are known as, what are they known as? Decoupling capacitors. So decoupling capacitors just help with a bit of noise, and they might stop the Arduino resetting in the event of a slight power surge. So if you can get, it's not essential you put these capacitors on, but if you can do, it's nice just to keep it nice and robust, and we'll give you some capacitors as well. Okay, so best of luck with it. Thank you very much.